Today I'm going to discuss factoring special polynomials. Now, if you remember how to multiply the special polynomials, this is probably going to be easier for you than some. The goal of this video is that when you're finished watching it, you'll be able to identify special polynomials and use the shortcuts to factor them. Before you can factor special polynomials, you have to be able to identify them. So here's how to identify them. Step one, look at the first term and then the last term. Are they both perfect squares? If so, you might have a special polynomial. Okay, let's look at this list. Let's look at the first one. Is x squared a perfect square? Sure. What about 9? Yep. The next one, 4x squared. Yep, that's a perfect square. The 9, again, yes. 2 is not a perfect square. 22 is not a perfect square. So we can say that is not going to be a special at all. All right, let's look at the next one. X squared, yep. 25, yep. 9x squared, yes. 16, yes. X squared, yes. 81, yes. Not this one. And even if I divided both of those terms by 7, I'd have an x squared, but then the 49 would be a 7, so that is a no. That is not going to be a special at all. All right, 16x squared, yep. 1, yep. 100, yep. 1, yep. Now, I'm not saying that all of these are going to be specials, but they've at least met step 1. The two different specials have different amount of terms in their polynomial. So I'm going to start with the first one that has only 2 terms, a binomial. So the question is it a binomial? Yep, all those are. If it is it a binomial with a subtraction sign? Whoops, there's one that doesn't, so I'm going to cross that one out. Between the two perfect squares, oops, this one right here with the 7 and 49, they're not both perfect squares. All right, so I've got the rest of them. So if it is a binomial with subtraction sign between the two perfect squares, it is the special called the difference of squares. So if you are taking notes, you need to write down difference of squares and write these two examples down. The next type of special is a trinomial. So are these trinomials? Yep, I got rid of everything else. So you're going to have to do some math with this next part. Square root the first and the last term. Multiply them together and then multiply by 2. If the middle term is that number, you have a special called perfect squares. So let's go ahead and do some math here. What's the square root of x squared? X. What's the square root of 9? 3. And then multiply that together. 3 times x is 3x times 2 is 6x. And that one works. Yep. All right, let's look at the next one. 4x squared is just 2x if I square root it. The 9 over here is a 3. And so 2x times 3 is 6x. And then times 2 is 12x. So yeah, that's it. Don't worry about the negative sign right now. Just look at the outside terms. All right, the next one. 9x squared, the square root is 3x. 16, the square root is 4. That works out for me. And so 3x times 4 is 12x, times 2 is 24. Yep, that one works. All right, let's look at the last one. Maybe all these work. I have the square root of 16x squared is 4x. Square root of 1 is just 1. 4x times 1 is 4x, times 2 is 8x. Oh, no, that's not going to work. So this one is out. So here you go. These 3 are examples of perfect squares. Make sure you go ahead and write that down in your note and write all these examples in your notes. Notice that you can have a minus or a plus sign for your middle term, but the other 2 terms are positive. Can you sort all of these polynomials into the 3 categories of difference of squares, perfect squares, and neither? Well, pause the video right now, try it on your own, and then come back and I'll show you the answer. Okay, here's the answer. Is this what you got? Can you identify why these are not specials? If you can, then you know you're doing well. Okay, now it's time to show you the shortcut in factoring the difference of squares. So if you see 2 perfect squares separated by minus signs, you're just going to put the square root of each of them here and here, and then one's going to be a minus, one's going to be a plus. And that's it. You're done. Next one. What is the square root of 4x squared? Well, 2x. And what's the square root of 9? 3. And then one has a minus, one has a plus. And really, y'all, it doesn't matter which one has the minus, which one has a plus. Your turn. Go ahead and pause the video, do these, and then come back and see if you have the right answer. Alrighty, the square root of 49x squared is 7x. The square root of 1 is just 1. 1 is minus, 1 is plus. Is that what you got? Next one, the square root of 16x squared is 4x. The square root of 25 is 5. And then again, 1 is minus, 1 is plus. All right, that easy. I have 3 more thoughts about the difference of squares before I go on to the next special. First of all, just because it does not start with a variable doesn't mean that it's not special. Those are both still perfect squares. It's just that the variable is at the end. And so this is how it's going to look. Please do not flip it around just to make it feel better. Next one, 50 and 8. They are not perfect squares. So is this not a difference of squares? Well, let's take a look at this. Both of them can be divided by a 2. And when I do, I get this 2 followed by 25x squared minus 4. And those are perfect squares. So now I'll just continue it. 5x minus 2 and 5x plus 2. All right. What if you completely forget about how to do this and you're like, I don't remember? That's okay. We can do it the original way, but you need that middle term. So what number made the x go away? A 0. So I can do 4x squared plus 0x. I need to keep that negative with my last term like that. And then I could do normally, what are the factors of 4 that are going to subtract to be 0? Well, those are going to be 2 and 2. One of them's going to be negative. One's going to be positive. So I'm going to go ahead and do grouping here. 4x squared minus 2x plus 2x minus 1. I'll get a 2x. Inside I'll have a 2x minus 1. And over here I'll have a plus 1. And then inside a 2x minus 1. And so finally I have 2x minus 1. And then the outside term's 2x plus 1. Bam. So a lot of work, which is why it would be really good if you could just learn the trick. If you can identify that something is a perfect square, the factoring part is easy. It's just going to be one binomial. I'm going to square root the first term, square root the second term, and then whatever this sign is going to go in the inside. So basically whatever this sign is of the b term goes in the inside here, and then squared. Done. Over here, same thing. I'm going to already go ahead and put that there. What's the square root of 4x squared? 2x. What's the square root of 25? 5. What's this sign? Plus. And I'm done. That easy. Both of these are perfect squares, but it's your turn to factor them. So pause the video and then come back when you're ready to see the answer. Alrighty, here we go. 49x squared, the square root is 7x. 1, the square root is 1, and this sign right here is a minus sign. Is that what you got? Next one, I have a 3x for my first term, a 4 for my second term, and another minus goes here. Bam, done. How'd you do? All right, I have 3 more thoughts about perfect squares. First of all, it is okay to have the variable at the end. We're just going to do this. 49 squared is 7. X squared is x. I'm going to put a minus there because that's in front of the 14 squared, and I'm done. If you look at the next one, it's not surrounded. The first and last are not perfect squares. But again, if you look at this, you might notice that, oh, wait a minute. Every one of these can be divided by a 3. So if I did that, what would it look like? I'd have an x squared plus 8x plus 16. All right, well, let's check to see if this is a perfect square. X is a perfect square. 16 is a perfect square. Great. The square root of x squared is x. The square root of 16 is 4. 4 times x is 4x. Double that, 8x. Good. That's my middle term. I'm ready to go. So now I'm just going to say x and 4. Put the plus sign here. Don't forget the square sign. Bam, done. All right, the last one. If you forget how to do this shortcut, then just do it normal. Look at this and say, all right, I'm looking at the factors of 4 that add up to be negative 4. And so is that 1 and 4, 2 and 2. That's 2 and 2, and they're both negative. Alrighty, so I'm going to do grouping again. 4x squared minus 2x plus 1. And I'm going to do a 2x. Pull out, and I'm going to have 2x minus 1, and then minus 1. 2x minus 1. I'm going to run out of room again. And then the insides, 2x minus 1. The outside's 2x minus 1. And anytime you see that they are exactly the same thing, then don't write the second one down. Just put a little squared after the first one. And there you go. All done. All right, it's your turn to go and have some fun.